Let's say you're on a raft in a pool. If you pull on a string tied to the pedal of a bike, does throwing a rock into the pool make the water level go up, down, or stay the same? Purple, because aliens don't wear hats. Hello and welcome back. Today I'm going to tell you about a useful technique for answering critical thinking problems. When you're trying to predict how a situation will play out, it's surprisingly helpful to consider extreme examples of the case. Let's look at one of the physics riddles I was talking about in the intro. You're on a raft in a pool, and you're holding a rock that will sink in water. When you drop the rock in the water, will the water level go up, down, or stay the same? If you want, pause the video and try to answer this question. Spoiler alert, it goes down. Sorry, probably should have given you a little more time. But now, to explain why it goes down, let's consider an extreme example. We know that the rock is more dense than water because it sinks in water. So now imagine something that's super dense. Instead of a stone, you're now holding a tiny chunk of a neutron star that weighs several hundred pounds. While it's on your boat, it pushes down with a lot of force. This pushes your boat deep into the water. Now imagine that you throw the chunk off the boat. While it's still in the air, your boat will rise back up because it's a lot lighter, and the water will go back down because your boat isn't displacing it as much. So now the water is at a lower level than it was at the start. Now let time move forward again. The chunk of the neutron star lands in the water. How does this change the water level? Well, it does raise the level a little, but because the chunk is so tiny, it displaces very little water. This means the water doesn't rise back up to the level it was at in the beginning. So as you can see, considering the extreme case of a super heavy rock can really help you predict how this situation would play out. The other riddle in the beginning is pulling on the pedal of a bike and which way it will roll. Specifically a bike in this setup with the pedal on the bottom and you pulling backwards. See if you can answer this one. Well, actually, it sort of depends. Okay, well, to be fair, it's almost always going to roll backwards. It seems really counterintuitive for it to roll backwards, and if you try it, it feels weird, but let's use this trick to explain why it rolls backwards. In this case, the deciding factor is the gearing of the bike, which has two extremes. The first, and what's on almost all bikes, is a gear ratio that means the pedal moves slower than the wheel, and as a result, the pedal moves slower than the ground. If you think about it, it makes sense why this gear ratio is on most bikes, because it allows you to move faster on the bike than you could walk. The other very rare situation is to have pedals that move faster than the wheel, or more specifically, pedals that move backwards relative to the ground. This doesn't exist on any commercial bike. I mean, just imagine trying to pedal faster than you're actually rolling. It just wastes a bunch of energy because the bike's actually slowing you down. So now you can imagine the extreme end of each of these situations. Let's start with the more realistic, low gear ratio. Imagine a gear ratio so low that the pedal could barely move, but the wheel would move a whole bunch. Let's just say that for every rotation of the pedal, the wheel goes around 1 million times. So in this situation, the pedal's barely moving, it's basically fixed to the frame. So just imagine that you're pulling straight on the frame. Once you think of it more like pulling on a fixed object, it becomes clear that the bike would roll backwards. But now to be sure, let's consider the opposite situation. Imagine that you have to rotate the pedal 1 million times just to rotate the wheel once. In this situation, pulling the pedal towards you drives the bike a tiny bit forward. The important thing here is that in both these situations, the pedal is physically moving backwards relative to the ground. But the real question is whether the pedal can move backwards while the bike is still moving forwards. Thinking about this makes the answer to the original question pretty clear. The whole point of having a bike is to make it easier for you to move at high speeds, so we can reasonably assume that the pedals aren't going to move backwards relative to the ground. Now every once in a while, your physics professor will decide to be a jerk, and they'll pull out some specially made bike with a high gear ratio that will roll forwards. But this type of gearing just doesn't appear on real bikes for the reasons I just listed. When I was taking Physics 1, this was honestly one of the tricks that helped me so much to succeed. In fact, for physics, intuition was one of the most important things. Obviously, you have to plug numbers into a formula to get an exact answer, but having an idea of what to expect can help a lot with the harder questions. But anyway, thanks for watching. I hope you enjoyed this video and that this advice can help you with random physics riddle videos, or maybe actual classes if you're, crazy. But anyway, I'm Gunnar. See you next week.